All right, I'm gonna do a little bit more coding on this chess AI. Um, the past few days, or not few days, the past few times I've been trying to play with this stuff, it hasn't been working. And so I think this session I'm just gonna do a bunch of like debugging, verification of my assumptions, make sure everything is working the way I intended to. I think theoretically what I'm doing should work, but for some reason it's not. So something is wrong, right? Something is wrong, um, and yeah. So the challenge is just find out what's wrong and get it back to where it should be. So what's happening right now? In fact, I can actually show. Oh, maybe I can. Do I have TensorBoard open? Is it running? Maybe I turn it off. Yeah, I turn it off. Did I reboot this computer? Oh, yeah, the computer got rebooted. Okay. I have to restart TensorBoard. I like to run it in a screen. Go to my chessbot directory. And it's not in my history for some reason. Okay. Will this work? Actually, let me just do this. All right. So I think if I have the log still up, I can show you what's happening. Oh, okay. Well, this is the most recent log. So one of the things that we're seeing is like the reward is getting worse, or it's just saying like I set it up to output the reward that the bot is receiving every game. I changed it a little bit. Previously I had just recorded the reward at the end of the game on the last move, which is just a win or lose reward. Now I have it set to be the full reward, including material gains. But yeah, it's getting 0 reward on average. It's just bouncing around the average. So something's not working right, and I gotta figure it out. So that's the current status. I think my current idea, I wrote a couple tests that didn't catch anything. Everything seems to be working. In fact, even if I have a test that that looks at sort of just two, I have a look at a position in the Joka piano where, you know, if you, it's like not an interesting position, but like I have one move that I try where I'll just show you. Well, let me just quickly show it to you, then I'll get back to coding because I don't want to spend too much time just going over stuff I already did. So I was looking at this position, and I just have I show the computer this move, right? If you go like this, it looks like you win a pawn, but then on the next move after that, you lose your knight, right? So I show that to the computer over and over again, and eventually it learns to minimize the Q learning loss. But the problem is the Q learning loss is this like consistency thing. So it's trying to maintain that its estimate of the immediate reward plus its own estimate of future reward is equal to the its estimate of like immediate reward. So there's like it's trying to be consistent with its estimates over time, like for the next step and for the step after that. And that's what the TD learning step is. And it's not I mean that part's working, so that doesn't explain the behavior that I'm seeing. So the other thing I was thinking of trying is I'm going to run the training algorithm with, rather than starting from the beginning of a chess game where there's so much complication, I'm going to start from a simple position. And I set it up, and I think it's ready to go. So I can run it and see what happens. So I set it up for a simple checkmating pattern. So I want the game to start like this. And And the intent is that, you know, white should be able to win this, right? If it's a good AI, it should be able to win it. It might turn out that white might still win it, like by just like making random moves. If that happens, then this won't be a good test. But let me think. So I mean, and this is not an immediate mate. It's a mate in 6. It's a mate in 6. So it does take some, you know, it does take some understanding of, you know, what lines the queen cuts off, and avoiding stalemate. Right? I mean, the main challenge here is to avoid stalemate for, you know, for beginner players and for players, you know, under time pressure. This can be a little bit somewhat challenging. Slightly. I mean, it's not that challenging once you practice enough. Although I think I messed one of these up earlier today in a blitz game. But so yeah, if you know, I'm setting up the game like that and letting the white player try to learn to win this position, and I think the only other changes, I mean, I think I can just run and see what happens. Let's see what happens. Okay, so a bunch of draws. I added more stuff, like I added this number of games per second. Wait, 0.33? That doesn't look right. Am I calculating this wrong? Looks like it's a lot faster than that. I think I'm calculating it wrong. Okay, finally one. Okay, something, obviously I'm calculating number of games wrong, so, or number of games per second wrong. So let's look at that code. I have it here. So this is how many games have passed. So this is how much time. This is how much time has passed. So do I just have this? Should it be the other way around? It should be step over elapsed time. Step over elapsed time. Right? Because if you played 4 games in 1 second, you wanted to say 4 games per second. Okay, yeah, okay. So, all right. It's played a bunch of games. It's won twice. I don't think it's learning anything. I suspect it's not. I mean, all right, let's look at TensorBoard, see if there's any clues here. So the reward value, I don't know, you might argue that what started low and ended up a little bit higher. How is it getting a 1 reward? Oh, it's because I'm smoothing it so much. Let me turn off smoothing. So yeah, I mean, it won twice. These spikes are the wins. These appear to be plus or minus 9. So this is like whether you have the queen or not. Oh, I guess you get a minus 9 reward if you lose the queen, and a plus 9 reward. What would be the plus 9 reward? How did I get plus 9? Oh, I know. I made a mistake. So that's a bug. The bug is that let me cancel. I don't think it's learning. I think it's just playing random moves, and that's the win rate you get when you play random moves. This I don't want. Here, this one. When I calculate the reward for draw, I changed it a little bit so that it's now the negative of the material count, but actually I think I want it to be the positive of the material count. And the reason for that is, like, if you reach a drawn position, you should sort of lose credit for any material you gain, or vice versa, right? If you have lost material and then you are able to make a draw, you should sort of get credit for that material back, so that the whole game was worth 0. So this would be, I mean, originally I had just set this to 0, which would incentivize the bot to take as much material as possible, and then and then if it reaches a draw, it's fine. It gets to keep the material. It's like it cashes out at the casino. That's probably easier. I mean, if I do the material count, I think the question is, what did I code this? This is the count material for the new position for a player to move. So this would be, so it's saying if it's the current person's turn, you get material difference plus. So if it's white's turn, you get if it's white's turn, you get credit for white's pieces. So shouldn't the reward be negative? So if you want to, shoot, I lost my place. It's in the main function. Not there, here. So if it's white's turn, oh, it depends on whose turn it is, because, okay. Right, I don't know whose turn it is. Okay, so I guess I'll say okay, and then I'm just gonna say reward equals material if board dot turn equals chess dot white, else minus material. Okay, and let me just think about, did I have that backwards? So if it's white's turn and it's a draw, the reward is, no, it should be minus here. All right, if I run this again, I should never see a positive 9 reward. So that will at least fix this bug. That's not the reason it's not learning. Like, it's not learning because something's wrong. But okay, and let's reload here. Yeah, okay. Those numbers look okay. So sometimes if it wins, it'll get 100 reward. If it doesn't win, if it loses the queen, it'll get -9. But then why wasn't it a draw? What did it do that it lost the queen but then didn't get that queen back for making a draw? That's weird. So the game end should either be a +100, -100, or maybe I'm just overthinking it. Maybe I'll just set it back to 0. It's probably better to be 0. So the idea is you don't get, if you make a draw, you just get 0 reward for that last turn that led to the draw, whether it's a stalemate or maximum number of moves. I'm not doing threefold repetition. I'm just saying 100 moves and then it's a draw. But you just don't get credit for that last move, or you don't get any benefit for making that last move. And yeah, and so this bot might at some point be incentivized to like capture a bunch of material and then stalemate the opponent. But it should, if it can find a checkmate, it'll get +100. So it'll prefer that. So all right. So now the question is, why is it not learning? Why can't it learn? So let's look at these. This is the reward. I'm also printing out loss, and the loss is slowly growing, which is different from when I have a test here where I just keep passing in the same moves over and over again, and that loss shrinks to 0 very quickly. So I give it two different moves over and over again, and this is the loss over time. So it starts at 6, it becomes 1, it becomes 0.6, 0.5, 0.1, 0.1, 0.05, all the way down to 10 to the minus 18 and smaller, 10 to the minus 30. So it's like it's like really nailing the Q values that are the action score values. And in fact, the position should lead to a -2 for when you trade your knight for a pawn, or 0 if you choose a different move. Or this is a more standard opening move, and it's a 0.00 position. And it learns minus 1.9 instead of 2, and it learns 0.01 instead of 0. So that should be fine. That should be fine. All right. So then the problem is that the actual learning algorithm doesn't actually learn. So maybe that means that I'm giving it incorrect information. Let's look at what I'm actually passing it. So I run the game here. This loop plays the game. Let me mark this up so I can see it better. So play a game, and it adds all the positions that white sees. Oh, I changed this here. I now have it used an epsilon-greedy strategy, and I have the probability that actually don't. There are other approaches to this, but I just have the probability of choosing a random move be. Oh, is this my problem? Okay, I have it right now. Okay, so epsilon-greedy means that with some probability epsilon, the AI will pick a random move, a random legal move. And yeah, this is absolutely what's wrong. Okay, so this might be the whole bug. So it would be cool if this works. But I have it set so that it's epsilon shrinks with every time step. So epsilon is now calculated as this value, which is 1 over t, where t is the step we're on, or the game. Like if we play 50 games, t is 50. So I have it set as 1 over t. But what I just fixed is that I had it set to play with probability like 1 over 50. It was going to play the correct move, and the rest of the time it plays a random move. So this has been just playing random moves on me the whole time. So maybe that's what was going wrong. Yeah. Otherwise, it plays the actual engine move. This engine's move. And all right, let's try running it. Maybe it's gonna be able to learn this simple version or simple endgame exercise. I ran the test. I didn't mean to do that. All right. A bunch of draws so far. Until it gets a win, it's not going to have any signal. Oh, it got a win. So this is an unlosable position, by the way. So that's why we're not seeing any losses. 2 wins. Let's see if we learned anything. We'll look at the tensor board. Reload. So the loss is still non-zero. It's getting bigger, but that's weird. All right, it's got a positive value on the mate flag. Not learning anything for queen. Oh, so queen, it learns queen is worth around 0.8 for now. Not looking good yet. Result, reward. Yeah, it seems to not be doing anything good yet. Mate is a flat value. Oh, average loss went back down. I mean, it's collecting a huge data set of games where it's drawing, and it's probably drawing, given the fact that it's initialized as a random, and to make random moves, it's probably drawing by picking random moves until it hits the maximum 100 move limit. I don't know if there's anything in the images might tell us and give us a clue. If I look at so king, these are the squares that it thinks the king should be on, I guess. Queen, I mean, this looks totally random. I think. I mean, it won a couple games, so does it have any information from those wins that it can use? No, I mean, it still hasn't won. It hasn't won another game since then. So it won 2 games, and it's just drawing every other game. I think this could be a sign that the epsilon is... See, now it's just picking the best move. Yeah, so here's the thing about the epsilon-greedy. The trick is to lower epsilon slowly because you want to try out different moves. Like it's an exploration parameter, right? If you have epsilon, the bigger epsilon is, the more likely you are to try a move that you're not sure if it's good, right? You don't think it's good, so you're going to try a random move, and then you learn about whether that move was useful or not. And I think epsilon has gotten too small. I won over, it's played 200 games, so it's 1 out of 200 times it'll play a random move. So most of the time it's going to play what it thinks is the best move, and it's learned really well to get a reward of 0, and it doesn't really think you can get any better than that. So, which is silly because it has 2 examples of winning. But all right, let me try changing the epsilon strategy. So let me minimize that. So this is epsilon, so I'm gonna just make it so easier to read. Epsilon and epsilon equals this. So I guess we'll do, I'm just curious, if I did 1 over square root of, let's say, 100, what is that? That's 0.1. Square root of 200, that's 0.07. That's still too fast, I think, given the, I mean, I'm expecting that we need to continue making randomish moves for the first, let's say, 10,000 games. Let's say that. This also messes with any I read like the DeepMind deep Q learning paper. I think they set it to have some schedule, but then they fix it to be never less than 0.01. But that still seems kind of small to me. So what if I add a bigger number here? No, that's not what I should do. How do I make this bigger? I guess I would make it, I mean, if I do, okay, so if I do this, so that slows down the rate that the denominator shrinks, but I also want to make it, let's just divide this by something. All right, let's think about it. So what does this become? I'll just check it. So let's just try a number. Let's try 1,000, and then we divide by 100. It's +1, but the +1 is because we don't want it to be because it starts counting at 0, so I don't want to divide by 0. All right, so it's going to be 0.3 probability of a random move at after the 1,000th game. That's pretty high, so maybe 100 was too much. Let me just divide by 10, should be fine. Then it's 0.1 probability after the 1,000th game, and then if it's a 2,000th game, 3,000th. That seems fine. Let's divide by 10. All right, I'm just eyeballing some numbers. Let's see if this behaves any better. Yeah, I think it just got stuck and it had no chance of winning because it was trying to play its best move, but it had no idea what the best move was. So it like was trying to play optimally before it learned enough about the position. So for example, like this is the game 40, so it should be playing a lot of random moves still. Yeah, I don't know. I mean, maybe it's just still not working because it like knows a path to win. It knows a series of moves that let it to win. So if it were to just train to get those values correct, it would know how good those moves are. But it's won once and that's it. It's increasing the estimate on queen. Mate, it just thinks is like a tiny fraction reward. The loss is increasing. Will it shrink back down? No, it's just getting bigger and bigger. You see, this is the behavior I saw on the full game, is that the loss kept getting bigger. I mean, there is a big difference though, because this bug was pretty critical. If I was, wait, let me check my logic again. So I'm picking a random number from, let me make sure this should be a number between 0 and 1. Yeah, between 0 and 1. So if it's less than epsilon, then we're going to make a random move. If it's greater than or equal to epsilon, then we choose the best move. Yeah, that seems correct now. But yeah, this is not winning at all. It's just constantly drawing. Played 200 games. Yeah, and the loss is getting worse and worse. So I'm also using this optimization algorithm called RMS prop, which is maybe root mean squared propagation. I actually don't know why it was named that. But it's this trick that uses a running average of the size of the gradient, and I don't know if I want to continue using it. I can turn that off. I would just turn that off. The way I can turn that off is by just uncommenting. Yeah, uncommenting this line would do it. So let's see if the loss is more stable this time. So okay, so no wins so far. So we didn't even get lucky and find a win. Without a win in this, there's no signal. I think the only signal is potentially losing the queen, which is, wait, how do you even? Oh no, I know. Yeah, I see how you lose the queen in this position. This might be pretty confusing for a bot because so a bot is trying to a bot's trying to find the checkmate pattern, but like, having the queen right next to the king is good for checkmating, but bad when the queen is unprotected, right? So there might be some tricky stuff that's hard for the learning algorithm to represent. Yeah, it's not winning any games. Well, let's see if there's any other clues. Yeah, so the loss is not changing at all because there was no signal. None of the weights changed. Nothing ever changed on the green curve. Green curve is just flat everywhere. because it thinks every single possible move is worth 0, so no move is better than any other move. So it never lost its queen, and it never checkmated. And those are the two possibilities. So I have the learning rate as at 0.001. I have the discount value at 1.0. Now that might be a problem. I want the discount to be 1 because I don't want... I guess the principle behind the discount is not that you don't care about future rewards. It's because the future rewards are uncertain. Yeah, and only in like forced mate lines is the future reward certain. Most of the time, when we play a move in chess, we can kind of look a few moves in the future and make a guess, but we don't really know what the opponent's going to do, and oftentimes it's hard to really predict. So it might be worth lowering this, but I don't think that's a problem. I mean, I'll just try setting it to 0.8. So that's this discount. That's this discount term. Okay, I'll try that. I don't think that will make a difference. I'm also clipping the gradient to make sure it doesn't get too big. That's somewhat of a hack that other people have reported works well in, or helps in reinforcement learning. Yeah, I don't know what else. I don't know what else to try. Yeah, so now that it's not even, ever winning, what did I change that caused this? Yeah, so whenever it doesn't win, there's no signal at all. Okay. I guess it's worth trying. I'll just try it from the beginning of the game and see if we get a different signal. I'm going to clear away some of these logs. They're not useful except for the recent one. Okay, so average loss is like this. It won a game, it looks like. It lost the game and won a game. The reward value is like this, so I guess if I zoom in to the rewards that are less than 100, we can see, oops. Yeah, so at some point it was like up a queen. At some point it was down a queen. This is up a queen and a pawn in different games. And this would mean that it was up a queen and a pawn when it drew somehow, whether it was reaching the maximum move limit or actual stalemate. Here it was down quite a lot. Yeah, I tried at some point earlier. I tried, turning off the win rewards so that it wasn't even incentivized to win, and all it was trying to do was capture material, and even that didn't converge. But now I'm wondering when I introduced that epsilon-greedy bug, because that would have been pretty critical, right? So not, I mean, this number, I want these to go towards 0. Like if this keeps growing, that's not good. I mean, this is if we smooth the curve, this looks like a growing trend. That's not good. We want it to be shrinking, or it's okay if it goes up and down, but eventually it should settle on a relatively small value. That's small. That's strangely small. The reward values are, I don't know, maybe increasing. Oh yeah, so I also turned off temporarily the thing I set up last time where I have it updated the weights, so now it's just it's playing against a truly random opponent. It's not even the opponent's not even trying to capture material, it's just playing truly random moves. But yeah, this reward doesn't look like it's increasing. Over here it looked like promising because there were a bunch of wins and there haven't been any losses, but this doesn't look so great anymore. What are we at? We're at 0.4 games per second. That's pretty slow. Yeah, when it was in the end game, it was playing really fast. Oh, it lost another game. So it's played 95 games. It should still be playing a lot of random moves. Right? Let's just calculate what does this formula come into at around 100. 1 over square root 10. Yeah, so like every third move it plays is random. So I guess it's likely that it might be better than we're showing, that we're seeing it play poorly because it plays a lot of random moves, but it won't play as many random moves as it gets more experience or as epsilon shrinks. But I don't know. Let me think. What else can I do to debug this? What other sanity checks can we do? Trying the checkmate pattern. I mean, mate in 6 is really hard, so maybe I could give it a mate in like 1 and see what happens. Right. If it has a mate in 1, if I give it a mate in 1 position, it better be able to learn to mate in 1, right? Like that's actually, maybe that's what I should do, because this is, I don't know what we're gonna learn from this. Because if this works, that's great. If it doesn't work, I don't know if that means anything, and it doesn't look like it's working. So like this should be growing more, I think, if it was learning well. All right, let's try the mate in 1 position. So oops, let's bring this back, and I'll change the fen to an even easier position. So let's do, whoops, board editor. Let's empty the board. Oops, clear board. Let's put the black king there, and we'll put the queen here. Oops, wrong queen. Okay, so yeah, mate in 1. There's 2 available. I don't think I want to give them 2. Let's give just 1 possible mate in 1. So here, I think there's only 1 possible mate. I mean, there's lots of mates, but there's only 1 mate in 1. Let's verify that. Yeah, this is mate in 2. Lots of mate in 2, but okay. All right, let's do it. that right? Okay. Okay, it's got 29 wins, 25 draws. Win rate is around 0.7. How much of this is just the epsilon-greedy part? Because epsilon-greedy prevents it from being able to make the best move, so maybe it already learned the best move. So this is of course too easy, right? All it has to learn is that a queen does well on what, B1 I think was the mating square. So it's like, yeah, let's verify that. We should see on our the square tables that queen B1 is good. So let's look at, I think this is the one. Waits P queen. No, wait, that doesn't look good. Doesn't what? That's not. Is this correct? This is the run. Oh wait, which one is this? This is 623. That's not. No, that's not it. It's this one. This is the one that's running. Yeah, this is the one that's running. So, yeah, so it has no weights for. Okay, oh, here we go. Yeah. Yes. Okay. So it did what it's supposed to do on this simple task. Well, that's not helpful. When you're debugging and you give it a simple task, the best thing is if it fails, right? Then you can figure out what's wrong with that problem, and then hopefully that solves other problems. But this seems to be working the way it's supposed to be, and its win rate is now 93%, and I suspect that's almost all the epsilon-greedy, because there's a huge reward, or the AI knows that it does really well with the queen on this square. This is a different run. Why is this showing me different? I think TensorBoard is messed up. Like, I have no runs checked, but it's showing me stuff. But I want to see nothing. Let me try reloading. Okay, turn these off. We just want this one. Yeah, so now we're seeing one run. Average loss looks like this. Smooth it out. Looks okay. That could be arguably learning. Let me turn off the smoothing. Okay, it really likes mate. It, I guess it cares about the queen, but more importantly, it's worth seeing. Okay, there's the king. It wants the king to be there. Looks like there's all these other squares that are lit up, which means that there are other games where maybe it won and it moved the king around. And then, queen likes to be here, and then again, all these other squares are possibly games that it won, but it ended up, chasing the king around and won after many moves. Yeah, sounds like this part's working. So I'll just cancel it. So one thing to note is that the win rate starts out pretty low, but a lot of that could be the epsilon random moves. And then once epsilon is small enough, I mean, what is this? So this is 4,000 games. Let's just eyeball this. So here the win rate was, let's go even earlier. So let's see here. Here's one. The win rate was 75%. So 75% of the time it was winning, but this was on game 209, and epsilon at that time was square root 209 divided by 10. That's my formula. Yeah. So right. So 20% of the time it's making a random move, and that's totally consistent with this. Not precisely, but it's pretty close. So yeah. Oh, that's weird. 20%. So it still has an opportunity to win after making a random move, but I guess it's hard to make if you have to make a series of moves. You have a probability of making multiple random moves. Okay, so that's not good. I mean, that's not. It is good. It's not helpful because it worked. That totally worked. So let's try mate in 2. Why not? Let's just see. I don't know. Maybe there's information in. I mean, there isn't information though. Like, what else could? All right, this is a mate in 2, right? Okay. So yeah. So it's black's turn. Let me go back to the. Well, whatever. I'll just move here. Okay. So this is a mate in 2 position. There's a bunch of possible paths to checkmate, but let's just see what happens. That's interesting. So now what's interesting is there's more than one move that will lead to checkmate, and they're all equally good. Okay, so wins are not as easy, right? So, but still, it's learn. I think it's gonna learn. I think this is gonna work. You can ignore this win-loss ratio. I had a hack in there to make it so that it does not divide by 0 because there is no losses. This is actually infinity, but I hacked it in there so it wouldn't be divided by 0. Yeah, let's look at the tensor board. So king, it likes to stay there. Does that seem right? Yeah, I guess that's right because you can just move the queen twice and checkmate. The queen squares are, well, that's weird. Let's see. Does that make any sense? Why would it want to be in the corner like that? That doesn't make any sense. So I don't think that's where it should be on those. I mean, weird. Average loss. Oh wait, which one we're looking at? Blue. Okay, it's not sure that that's learning correctly. It looks kind of like it's not, but the reward value is getting higher, which is good on average, but a lot of that could just be epsilon. So we're at 400 games. So 85% of the time it gets to play the optimal move, or what it thinks is the optimal move. And given that it has to make 2 moves in a row that are correct, it could have learned the correct strategy at this point, right? 59, 60%, basically 60% wins. Maybe it's learning. Again, this doesn't help because it seems like it might be working. I mean, this loss going up is not good. But the result going up and the reward going up is good. I don't know what would explain the loss going up. You know what I could do is I could like periodically have it play at full strength, like turn off epsilon, um, to measure how well it's doing. Because we're kind of guessing about two things, right? Either it's learning poorly, like or the epsilon values making it, throwing it off track, and it's not able to recover. Also, I don't think I'm seeing any cases where we get -9, which should be possible. And so if I turn off all smoothing, every reward value is either mate or no mate, and it's never -9. It should lose, it can lose the queen, but it's not doing that. You would think with random moves it might accidentally do that. Oh, I guess it. Yeah, right. No, I think especially because the opponent's also playing random moves, and so whenever the queen is in range, I think there's at most 3 legal moves. So there's a 1 in 3 chance that the opponent will capture our queen, and then we would lose 9 points. So I don't know why that's not happening. Yeah, I think I would say this is successfully won. I mean, learn to win. But the loss, okay, the loss kind of settled. Like that's pretty good. That plot is, I mean, it's not okay, the smoothing is too much. Like it looks like it goes up a little bit, and that's as it gets more experience trying stuff out, and then it starts to shrink, and that's good. And how many games did it play? It played 1,500, around 2,000 games. It played around 2,000 games, and it was able to learn to do this. I mean, it probably learned earlier. Like it looks like it learned earlier how to do this checkmate pattern. But it's just not. I don't know. So now, what does this tell us? Because maybe it does work. Maybe having it start from the opening is just too hard. Maybe the bugs are fixed. Oh, I turned off the RMS prop. Huh. Let me turn that back on and see how that differs. So we can actually, that's one really nice thing about TensorBoard. We can compare them directly. So let's do this. We'll run it, and we want to run it for roughly 2,000 games, but we can view it earlier. Played 50 games. All right, let's look at it now. See if there's anything informative at 50. Nope, nothing informative. I mean, this is a tiny sliver of what the last one did. So if we zoom in, it won't even tell us much because it's so noisy. Win rate looks roughly the same. Roughly the same. Yeah, the epsilon schedule is tricky because this is a classic challenge in reinforcement learning, this trade-off between exploration and exploitation, and even that terminology is a little bit jargony, right? So what people mean by that when they talk about exploration versus exploitation is like if there's a strategy that gets you a certain amount of reward, then you can exploit it. You can just keep using that strategy over and over again. And exploration is that you might try something that might be worse or it might be better, and you don't know if it's better or worse until you try it. But right, there's a risk. There's a risk that it might be worse, but there's a risk that you're missing out on a better strategy if you don't try other things. So the epsilon parameter determines how much you explore. The higher the epsilon, the more you explore. And what my formula right now is that it's shrinking slowly, but yeah, it's kind of a, I mean, you think about what happens as this thing learns, especially considering how complex chess is. For example, you could imagine it's like learning one basic opening. Let's say it learns how to play. What's something a computer might be good at, like a Scandinavian, right? Trying to open up the center quickly, and it learns how to play an open game, and then then all of a sudden wants to try out playing a closed game, and in that sense it like knows nothing about that game, so it really should reset its epsilon in that situation if it's trying a totally different style of play. But if instead it's not trying a totally different style, if it's trying a similar style and just trying like one slight change in how much it values bishop versus knights or something like that, it's that would suggest you don't need to change epsilon. But all right, so let's see what's happening with this. It looks kind of similar. I think if I smooth it out, it'll look the same. This loss parameter, the loss value, also looks pretty similar. Is this the whole thing? Yeah, it looks almost identical. So the RMS prop's not really doing much in this example. No reason to add it, no reason to turn it off. What else am I doing here? So I'm also doing, I have the replay buffer. So what do I have that set to? Let's see. I have it set to a small buffer of just 1,000 moves. I'm using a batch size of 10. So this is a mate in 2. So it should be, I mean, I could even turn on the bot and challenge it to this position. Would that be helpful? Probably not. I think it's worth trying. See if it works. Let's see. Alright, I will log into my personal account and challenge BertBot to a game from position. From position. Where'd it go? It's in the main. Oh, it's in the main loop. Okay. So it's white to move, and I'm going to play as black. All right. Okay, BertBot, show me what you got. Oh no, I'm white. Oh no, I'm black. Okay. All right, that's probably correct. So I just run away here, right? I mean, that's not correct. It was wrong. Yeah, so it's wrong. It's just straight up wrong. I mean, it's still gonna win, I think, or not. Interesting. Aha. Well, this is good. I was complaining that we didn't have any bugs, and so there was nothing to fix. But that was strange. It didn't play what it should have played. That was strange. Okay, so I have a plan. So now let's go back to, I'm going to copy this. I'm going to undo, oh shoot, okay. Let's go back to the mate in one situation. Redo, okay. Let's go back to mate in one and see if we can, because then that was like a pretty foolproof. I don't have it open anymore. Let's go to board editor. Oh, okay. All right. Okay, and I'll have it learned. Whoops, what did I just do? I'll have it learned to play this move, play this position. It hasn't won a single game. It won 1, 2, 3. Oh, okay, I think I figured it out. Number of wins just skyrocketed. Still has more draws than wins, but it's about to, yeah, wins just overtook. All right, so it figured it out. So, right, it just, I mean, what it should have found is like, put the queen on that square, and that's great. That's the best thing you can do. Actually, RMS prop didn't converge in the last run, so this is worth considering. Oh, okay, there, it converged later. I mean, this difference is probably just randomness. Okay. What am I doing? So I want to look at, oh no, I don't even care. So let's try challenging BirdBot again to the mate in one position. Okay, that's mate in one. I'm playing as black. Okay, let's see. Yeah, something's wrong. Could be something wrong with the loading script, or is it loading old weights? Huh. Did I forfeit the game? Do I have infinite time to start? Okay, fine. Well, okay, wait. Maybe it counts. Yeah, loading old weights or no weights. Yeah, it could be that. It's hard to tell because like those could have just been random moves. I mean, but no, it wasn't. It got a mate in 2. So on the previous, could it be learning to do? Let's try it again. Maybe it's learning to do mate in 2, because actually, based on the discount factor being 0, it doesn't matter if it's mate in 1 or mate in 2. Like it gets the same amount of reward either way. So it could have been that it's going to do that over every single time. So let's see. So will it play here? Yeah, I think it's learned this mating pattern. So it actually, okay, this seems to be working. Now the other one, oh, maybe the other one was working too, and I just wasn't. No, I drew the other time. The other time when it learned a mate in 2 pattern, it learned something that I could cause a draw. But it doesn't know about a draw because, well, if it repeats forever, then yeah, it would be a draw. Even because even in my code, I'm not checking repetitions, but there's a maximum move limit. So if it just repeats for 100 moves, it'll be a draw. So, yeah. So it is consistent that it did those two moves. Now that could have also been random, but I don't think it is, right? Its win rate is 94%. I think it's also playing in these games the same way. So it's a mate in 2. It's taking the mate in 2 path instead of mate in 1. And there's no penalty in either way, in either direction. Oh no, there is. Didn't I set it to 0.8? So there still could be something wrong. I thought I set this. Yeah, this counts 0.8, which means that if it knows that there's a mate in 2, and if it also knows there's a mate in 1 available, it would prefer the mate in 1 because the mate in 1 should be worth 100, and the mate in 2 should be worth 80. But it might not know there's a mate in 1 because it never tried it. So suppose it never tried the mate in 1. It's weird because the mate in 1, it should just be to read off that, oh, it's a checkmate situation, so you can get 100% on it. But yeah, I guess if it never tried it, it doesn't know that the mate flag is worth anything. All it knows is that it moved its queen to a different position, and then on the next move, it moved and got 100 points. So I would suspect if I run it again, it might not learn the same mate in 2 pattern. It might be a different mate in 2 pattern. Is there a fast way for me to do this? No, not really. Okay. So let's see. Okay, this time I learned the mate in 1. Rematch. Let's do it again. Oh, am I white now? All right. Let's see. Let's just mess around with it, see what it does. Interesting. Okay, now it's playing as white again. Will it do the mate in 1? Yeah, okay. Well, all right, so the mate in 2, it was not working. So the mate in 1 is working, mate in 2 was not working. So right, this win rate's not at 90%, so let's try it mate in 2. So I'll comment that out. So we're going to use this position. It's the mate in 2. So the weird thing is, again, in the training, it looks like it gets like a 90% win rate, but then when we play it on Lichess, it played something that led to a draw. So the win rate's 0.19. It's slowly crawling up there. A lot of that could be epsilon. Let's try it. Okay. I'm playing as black. I should have flipped this around. This position feels really unnatural with the king all the way at the opposite rank. All right, that move probably is. Yeah, it still works. Okay. Let's see if we try. Oh shoot. Okay. I'm playing. I'm white. my queen. Okay. So we'll come here again. Oh, it was here. Okay, so it cuts off. Yeah, sorry. Yeah. Okay, so it played the same pattern. This time it's working. So I don't know what happened that last time. Here, I'll just. What else works? This, I guess. So is it gonna? Yeah. So it was here. Oh, or it was there. Was that where it played before? All right, let's look at what squares it learned. So we want this one. Uncheck that run. So queen, it likes here, not there. So one of the things is that these tables are only part of the model. There's also the random features, which we can't really tell what they're doing. They're hard to interpret. There's random features. So there could be some logic hiding in there that the bot is learning to follow. And what else did it learn that mate is worth a lot? That curve looks really nice, the green curve. Oh, green's not even what we're looking at. Orange is what we're looking at. Still, that looks like it's shrinking. That looks like a good curve for the result. For the reward, that's good. Okay, so I was curious. Mate. It's slowly increasing its value, but it's only worth 4 right now. So they will break a tie, right? If it's not a big reward for getting checkmate. Yeah, it's one of those things. Previously I had been initializing mate to just like the true reward value, which I think is 100. So I just set it to 100, and that's reasonable. I don't. It's okay for me to do that, but it's because, like, why not have the bot already know that mate is worth mate, right? Mate is worth the full reward, which could be fine. All right, so this is frustrating. These tests are all kind of working. I can't replicate the one that didn't work. I don't know what happened there. But then as soon as I started from a normal position, well, let's start it from a different position. Let's do. I always click on that, thinking I will access the menu that way. Let's look at let's just pick one of these starting opening positions. Let's do something. No, I don't want to do that. Okay, let's do something really dynamic. Now let's continue. We'll move it further along. All right, so from here, yeah, what's interesting about this position is it appears uneven by material count, but modern engines and theory says that it's even. So yeah, let's try this. This might be an interesting test. Actually, let's go back. Why not? Oh shoot, no, that's not what I wanted. I wanted to go. Oh, I can't go back because this is not an analysis board. All right, let's go back to the Smith-Morra starting position. Smith-Morra. So at this point, we've traded the flank pawn for the center pawn. No, not traded. Okay, so at this point, white's down a pawn. Maybe I want to go back. So let's go to this position. So from here, this is a pretty dynamic situation, right? So, I don't know, I screwed that up. Yeah, it should be here. I guess this way, you know, it looks like an even trade for black, right? Like naively, it would look like you would do that. Oh shoot, I keep doing that, but I just lost all my pieces because this is not an analysis board. All right, so what do I have? I had a pawn here, I had a black pawn here. Now let's go to the analysis board. I don't want to. How do I flip? Yeah. So this. Yeah. Let's see what happens with the AI starting from here. I mean, I don't know what difference it makes starting from here versus the very beginning of it. Is it 2 R's? Is it 2 R's? Yeah. Okay. All right. Let's just run and see what happens. I feel like epsilon might be too high. Because it's gonna be a bunch of, okay, there was a win apparently. I don't know how that happened. A bunch of random moves. Yeah, I mean, maybe the next session is about speeding this up. I'm getting less than a game per second at this rate. You probably assume since all these are draws, it's playing 100 moves. I could reduce that number, like maybe we just say 60 moves or something is long enough to have any reasonable game. I've seen a lot of computer games, like computer chess games, play for 100 moves or longer. The complicated end game. But we're not that type of engine. We're trying to play we're trying to build a basic engine that can play, you know, decently, not superhumanly. I mean, I don't know. Maybe someday superhuman, but all right. So let's see if there's any material advantages that have come out of any of these games. So we're looking for the blue curve, and if we see the reward value, what's happening there? Oh shoot. Okay, reward. There was one game where we won. We had 103 reward, so we get 100 for the checkmate and 3. I guess we captured a minor piece somewhere. Let me turn off the smoothing for this because we're just looking at the individual games. A bunch of games where not much was exchanged. Sorry, I shouldn't say. I don't know that where not much was gained. Right? There could have been exchanges, but they were evenish. There's one game where we're down 10. A game where we lost. This game where we lost, but we were up material. We're up 2 points of material, and we lost. Here we were up 21. That's impressive. Let's see. Okay, another win. Yeah, I mean, I don't know if this is actually working, right? Like, it could be a slow climb. 2 wins, relatively close together. It could be a sign that it's starting to learn something, but probably not. I mean, I would expect the material to improve more, obviously, but it hasn't. I wonder what those wins look like. Anything else we can look at? So it thinks rooks. I started everything at worth 0, so it increased the value of rooks a little bit, then it shrank it back down, and these are all tiny numbers. Like it's 0.3, 0.2. Queens are worth 0.5 now. Pawns settled around 0.15. Knights are hovering around 0.2. Mates. Okay, so this is. Oh, you know what? Well, no, these numbers. Ideally, these numbers should be close to the standard material values because that's the reward value signal. That's the reward signal we're giving it. But here, like bishop's worth negative. But there's other factors, right? So there's the square tables that also add to the score estimates, and so it's hard to keep track of all that together. We can't just like look at the number. There's the king all over the place. That's a little weird. There's the random features which you can't even look at. Like the square tables we can plot and look at them, but the random features are just random combinations of squares and pieces in different positions, and the hope is that the AI finds some patterns in there that are useful for winning. These are the brighter the square, the more valuable it is to have a piece on that square. So this is where the king is really valuable here. This might be maybe a learn to castle. That would be impressive. I haven't seen one of these bots learn to castle, because that's lit up right there. But more likely this is, I don't see there's no reason that this should be working, because I feel like I haven't changed anything. Although the epsilon bug, I don't know when I introduced that epsilon bug. That was definitely a big one. Let's see. Oh, okay, reload. Yeah, I don't know. I mean, that doesn't look like it doesn't look like a solid improvement. It seems kind of, the smoothing gives us a clue. So it's like a slight maybe improvement. Whereas this stuff at the beginning doesn't really count. I don't know. I don't really buy it. So it's like it does well. It could just come down to the fact that I can't represent the board very well right now with these random features. Yeah, right. It could be that it's working, but it's just doesn't have a good board representation, and I should move to a full neural network, or I can increase the number of random features. Random features are a legitimate modeling approach. They are competitive with neural networks in many settings. So I could just increase the number. I just have it set at the same number of the original features, which is 395, but that number is pretty arbitrary, and we could probably afford computationally to increase it because it's just a matrix multiplication that the hardware is doing pretty fast. I think the biggest computational bottleneck here is the Python chess engine, the Python chess library. I think. Okay, bishops are worth positive. That's a good sign. Let's see. Rooks are worth 0. That's not a good sign. It's weird. Oh, I didn't have it zoomed to at the same level. All right, well, these losses went away, which is good. There's a bunch of wins. That's good. Let's see the smoothing. Yeah, I don't know. I don't know if that's real. If we zoom in on it, if we zoom in here, well, maybe like that. Yeah, that could be a legitimate improvement. Oh, you know what? It's also worth remembering the step size. The epsilon value. So right now we're at 150 games. Square root, 15. So every 4 moves is making a random move. So that is still pretty limiting. So it could have learned something good, but isn't allowed to act on it yet. Yeah, I don't know. So it might be that things are working, and I have to try it again. This is how I feel at the end of every session. I always feel like, okay, I fixed the things, and then now we don't know if it's working. Let's try running it for a while. That might be where we're headed again. So Moldylocks writes, I like your idea of debugging using a mate in small number of moves. Maybe a mate in 3 or 4 would show more info. Yeah, I did mate in 2, so let's try mate in 3. Why not? I mean, because what I'm doing, like, now I'm jumping to like an opening position, and it's so complicated. Like, how will we know if it's working? And then you're saying it would be interesting to see if the first few moves of each game printed in the output, and try to get an insight as to what the learning looks like visually. Yeah. That'll take a little bit more work to print out the games. One thing that would be really useful, especially visually. Right. So I have to figure out. I don't know how to print it. Like, if I could get it to output like a PGN format, that would be awesome, right? Then we could actually look at it in an analysis board, move back and forth, look at the different moves in sequence. I mean, if I could do that in 5 minutes, maybe that would be worth it. So, like, here, this is the loop that generates the moves. So could I somehow just, like, so I just have the moves. I could just, right, so I have this, I can print the standard algebraic notation of the moves. How close is that to a PGN? So I actually don't know PGN format, but let me see. If I were to start from, let's just make some moves. So we take this piece, we do this. Now the PGN looks like this. It's 3, wait. So it's number, then the name, then the algebraic notation for the move. Oh, there's a ... because we're starting from move 3. But if we start from the opening, like, just for example, if I were to try typing something in, will it does that work? I think it worked. It just flipped the board, so it's hard to see. So I just create this list of moves with the number. Actually, I think Python chess should be output this directly from the board object. So they have the PGN parsing and writing. So if I want to write a PGN, can I just do it directly from the board? Because the board has a list of, the board keeps track of all the moves that led to the current position. So can I can spend some time figuring out how to go through each move and output it in the correct format, but I really suspect this should be a built-in feature. So this is to read the game. Gets a board, apply, set up board. Game builder. That would be so cool to just print it out and I could just paste it into the analysis board. So I don't want a tree of moves. It shouldn't be so complicated. I just want a single line. But can I just generate that? I wish there was an example here. Print game game add variation move. So you get the moves. So I create a game object. I create a node. That seems too hard. I mean, too unnecessarily hard. But anyway, so okay, so I create. What are they doing? What are they doing? So they created a node. So okay, if I just create a game. Where I lost my place. Okay, this is nope. This is Q learning. I want to do in the loop where I'm playing the game. So okay, so at this point, right at this point, here's what I'll do. I'll just say. Here's where I'm printing diagnostic info. So why not print it here? So I'll just do like print game board. I had to make print game, but I think I have a board object at that point. I think I can do board dot no, I should probably just do the full board object. All right, so now let's create a print game function. Let's do it here. Okay. Move stack. All right, let me cancel this and I'll so what no, during okay while since I canceled that, let me just quickly look at what happened in this run. So yeah, it looks like it was learning. I mean, that the result it was learning. So maybe I fixed a couple of things here and there. That's worth. I mean, that's good. So I after this stream, I'll just leave it running for a few hours and see what happens. But in the meantime, I definitely want to get this is a great idea. I've been wanting to do it for a while, and so Moldy Locks, your encouragement has pushed me to try to get this done real fast before ending the stream. So let's see. So I don't. Yeah, I'm just gonna manually. I mean, if I just change this to nothing, actually, I'm just gonna like. Okay, like is that the correct format? Right, and then for 2, is there a comma? I already forgot. So let's just look at what it does. So there's no comma. There's just the space, and then you do 2 for the second move. All right, so this sounds pretty straightforward. So I just need to. There's one way to do it. I'm trying to check if that's like the correct way to do it. But one way I could do is create a new board and then just apply every single move in order. But there might be an easier way to do this. Well, let's just do it the way I think I can do it. It might. I hope it's not too slow. I want to call this. Sure, new board. And we're going to say new board dot push move, but before we do that, we're going to say so it's new board dot send move, and let's right, so I'm gonna create a list of these standard algebraic notation. Oops, I didn't. And I'm just gonna do that for now. And we'll see if that, and then if that works, then we just need to format it a little bit better. Missing positional wait, what? I need to give it a move. I thought I gave it a move. What am I doing wrong? Stand missing one required positional argument, move. I'm passing in move. Let's debug it. I think a lot of things are inefficient about my code, but one of the things that's really slow is it's loading TensorFlow, like the full library, when I just want the TensorBoard logging, but that's fine for now. All right, so what is wrong with this call? So new board.san move. Okay, so it's missing positional argument move. So what is a move? Is move what I think it is? It's a move object. New board is a new board a board object. So why? Oh, I think wait. I'm really confused. All right, it takes in a move object, which I'm giving it on okay. Let me think about this. Missing one required positional argument, move. How could it be missing? It's right there. I called this elsewhere. Yeah, that's the same way I did it just there. So what's wrong with this? Is this move the wrong object? Is move something? Yeah, move's a single move object. Oh, how annoying is this? This theoretically should move. I mean, should work, not move. but move is wrong. I mean, one possibility I thought of is that this might be backwards. Like the move stack might be storing moves in reverse order but I don't think it is. I think it should be in, if it's a Python list, then the stack implementation would put the stuff at the end of the list. But then this, I can't figure this out. I mean, like new board.legal moves. Let's see what that generates. Okay, it generates something. So let's do a list of them. Property is not iterable. Yes, it is. I totally do that later. Like I did this. Something weird is happening. Did I just oh oh, this is so stupid. All right, so I this right here, I was making it like the class object, not an instance of the class. Okay. Why don't we? I'm just gonna do that and debug here so we can see what happens when we run one line of this. Oh, didn't mean to do that. Okay. Okay, I will get this to work. So once I have the list, I just need to print like the move number between every other set of moves. There's a bug. The move is not legal, so I must be passing in. I'm passing in an illegal move. What move is illegal? D4, D5. Let's look at this one. So new board is on move 2, and it received a move that was not legal, which suggests the thing I was worried about, the move stack being backwards, could be true. Move stack is a list of moves. It doesn't make any sense though, because it what am I missing? So for every move in the move stack, we apply the move. Well, first we get the name for the move in algebraic notation. Then we apply the move to the new board, and then we continue. What's wrong with that? Am I playing from a new position? Oh, I'm not playing from a new position. I'm playing, this is the Smith-Morris start. So I'm not starting from, yeah, that's why. Okay. So those are not legal. It will make moves that are not legal because I will set this to be, let's do, for now, let's just do it from the beginning, because it was learning, and so it's probably worth for us seeing the full game. Okay, I hope this works now. Okay, so now I'm just thinking about, this is a simple CS0 problem. I have a list of stuff. I want to print a number between every other item in the list. Not every other item, every 2 items. So I got, this is the sequence of moves. What the heck kind of game is this? But no, it's fine. It's 2 random players for the first game. But yeah, so we want to print something like, I guess we want to add the number before okay, I know. I'll just do this. This is probably not the most Pythonic way to do this. So let's set it, move number equals 1, and we'll just say to print equals that, and we'll just do while nope. Let's do. See, it's just okay. What I'm annoyed about is there's this corner case where the game might end on white's move. White might have the last move, or black might have the last move, and that's the annoying thing. All right, but let's not overthink this. So why don't we say for I in range, maybe we'll do it like a C style thing. The length of stand moves, that's the total number of moves. I realized the other day, I don't know what people mean by ply versus move. I think I had it backwards. I think people in chess, when they say move, they mean like the first, the number of moves that you made, and the opponent makes, your first move, the opponent's first move, but that's actually maybe 2 ply. I don't know. But anyway, so now we're just gonna if I equals, okay, so if it's an even number, then we're going to add move. So we actually don't need move num. I think we just need this. So we're going to say to print dot append, and we're going to write dot format, and it's going to be I divided by 2 plus 1, right? So on index 0, it'll be 0 plus 1, so it'll be 1. And then otherwise, we just add to print dot append san moves I. I think this might work. Print, oh no, so, oh yeah, we are printing. Print san moves dot, wait, join. Will this work? Let's see. I think I'm gonna just run. Am I in the debugger still? I think I am. So I can actually run this code in debugger mode. To print not defined. Oh. Okay, that is. Oh yeah, I joined the wrong thing. I wanted to join this to print. Why is my computer working? Oh, I was like, why is my computer working so hard? But it's actually the it's just the streaming software. Let's try this. What? It's still complaining. What's the problem? To print. What is going on? All right, I'm just gonna. I'll just hit run. Let's see what it prints. Okay, it printed floating point numbers, which is annoying. So, since I'm already doing C style stuff, let's just do it C style. Python moved away from this. People like using the format command, but I mean, I've been a C coder, where I was trained in C, so this feels more natural to me. I don't know what the reasoning is to move away from it. Maybe just because, like, what does D mean? I actually don't even know what D means, but it means integer for some reason. Okay, is this, what happened? Where's the, oh, I forgot the period. Still running. All right, can we copy this into Lichess? This is 100 moves. Yeah, it's 100 moves. Yeah, so this is game one. Game one of our training run was this completely insane game. And turn off Stockfish so my computer does not explode. So yeah, so this is cool. So now we can look at later. If we let it train for a while, we can look at the games during training. We had to forgive it. It doesn't know the rules to chess, but. I mean, this is the first thing I saw. Probably there's already been a lot of things that I missed. Yeah, this is really, really helpful to have this. So next time, right? So now, after we finish training, we will, after I leave it running for a few hours, we'll be able to look at it and see what it's doing. Yeah, because before what I was doing is I was loading it into like, I was playing it on Lichess and seeing if it does well on, on a new game, but there could be additional bugs in that, right? Like maybe it's not loading the correct weights. We were sort of concerned about that earlier, but then after some testing, it seemed like it was loading the correct weights, but we didn't know that before, and so now we can actually look at. It's kind of weird to see all these captures, but I guess these are just random. Like among the legal moves, there are word captures available, so randomly you'll sometimes make captures. I mean, and then there was a bunch of captures it didn't make. All right, so that's cool. So now it's still running. We have all these games printed out. That's cool. What are we at? Now, did that slow things down a lot? It probably slowed things down a little bit. I mean, yeah, this stuff. Yeah, there probably is a faster way to do this. I don't know. I'd have to actually. I can profile it and see how long this function takes. This function here might be slowing things down. If that's the case, we can have it print only a few, not all the games. Yeah, at some point I can look into like a faster chess backend, but I really don't want to. But I mean, if this becomes a major bottleneck, then we'll have to do it. Oh right, so what I wanted to do is, so it's played 71 games. I doubt it's learned anything yet, but let's have a look. In the previous run, it started to really show improvements around game 200, I guess. Well, maybe arguably, I mean, with the smoothing, if you turn off the smoothing, arguably, it started to get. Well, it got like the blue curve got good here, and then it got kind of had like a slump. Oh, sorry, this is the average loss. I shouldn't look at that. That's not what we want to see. This is the reward. So okay, yeah, similar though. Actually, around game 50, it got good, and then it had like a slump here, and then it started consistently winning. So this is hopeful. I guess. Yeah, it's I can leave it running and see what happens. I think that's the best thing to say at this point. Let's look at the current run by itself. Whoa, there's so many runs. I had to clear these out. Let me see. So blue was the most recent one. So let me clear out everything except for the most recent two. This one's currently running. This was That's weird. The timestamps don't seem right. Well, I can always undo deleting if I messed it up. So let's reload. We should have two runs. One is... Now they switch colors. Blue. Oh, no, that's not good. Yeah, I messed up. It wasn't that. It was... One of the ones was... Shoot, what is the long one? I mean, we could also, it's not a big deal to keep this comparison. So the blue one that I'm looking at is this. So it ends in 4827. So I want to keep that. Although, yeah, it's really not critical that I keep it because it was just a debugging trial. Delete that, and we'll keep that. So this should be. Yeah, so now the orange one was the one we ran for a while previously, and then the blue one is the one that's currently running. I wish they would let me put the blue on top, but okay. So this is the reward that it's receiving, and the smoothing's not always the best sign, but we can get a better view. I guess it looks like the reward is increasing. I mean, it's clearly increasing. I mean, with this much smoothing, which is how I was looking at things in previous streams, but I started to get skeptical about it. I think it's over smoothing, and so it's not a very good clear picture of what's happening. Okay. Yeah, so this is not the actual run I want to do. I mean, I could just run like this, and then it will learn to play against a random opponent, but I did want to have it occasionally update. Oh, so what is it? It's playing a game every 3 seconds. It's really slow. I think it's really slow because a lot of them are draws and they're taking 100 turns. Let's be a little bit more. I mean, yeah, 100 is too much. That's probably I don't want to play 100 turns. Oh wait, is this 50? When I say 100, no, full move number is not, it's not, yeah, half move I think is the standard view of moves. So yeah, it is 100 moves. So I don't, that's too much. Let's do 60. I think a 50 move game is, yeah, I don't know. We might lose some information about end games through this, but it's worth it to like almost double the computational cost. Not double the speed. We'll double the speed, half the cost. All right, so I want to put this back in. So I had this code here, which occasionally updates black to match white's weights. And I realized that this is just steps, so I don't need to. So I'm doing 5,000 at this rate. It'll take forever. I mean, 5,000. So if I double the speed, it will be 0.6 games a second. Let's say it's 1 game a second. Let's say it's 1 game a second, because I think as it gets better, it doesn't go to the full time. So it's 1 game a second. So it's so every 5,000 games, it'll update black. So that would be 83 minutes. That's actually, well, that might be okay. All right, let's try that. All right, so I'm gonna leave that running. I'll do it in my screen. Let's do it here. Okay, and Python learning engine. And also, I don't know, I've been leaving my Lichess, the bot, running on the API, and then like random people keep playing it and destroying this really terrible bot, and the rating has been plummeting, but I'll leave it. I'll turn it on from time to time. I'll leave it on for now. So, oh yeah, then I also want to clear away this run, this recent. So now we want the red one, but not the blue one. Just for cleanliness, these trial runs that are not the critical ones are just too much to keep around. Okay, so I'm gonna leave this running, and I'll see what happens in the next stream. Hopefully we have some good news. All right. Hope that was enjoyable. See you. Have a good weekend.